This video is going to cover Unit 26, Section 3, Areas of Trapezoids. Now trapezoids, we've talked about those before, but a trapezoid is a quadrilateral, a four-sided object in which two and only two of the sides are parallel. So with this figure right here, if this side and this side were parallel and this side were not parallel, that would make this a trapezoid. Okay, so area of a trapezoid will be, area is going to equal base 1 plus base 2, and then that is in parentheses times the height, and all of that divided by 2. Now the two bases are the two sides that are parallel to each other. So let's put some numbers on this one. Let's say that this base is 8, this one is 12, and then we have to have the height in here, perpendicular there, and let's say that that height is 6. So putting those numbers in here, I would have the area is equal to 8 plus 12 times 6 divided by 2. So let's see here, this is 20. Now what I'm going to do here is I'm just going to reduce this 6 and this 2 right now. I'm going to say 2 can go into 2 one time and 2 can go into 6 3 times. Now you don't have to do this kind of thing. The only reason I can do that is because 6 is even. If it's not even, I'm not going to mess with it. So, but that eliminates the denominator for me. So now all I have to do is add these two together and then multiply it by 3. 8 plus 12 is 20. 20 times 3 is 60. So the area of that trapezoid is 60. Okay, so let's move down here to on page 665. We have this example right here, and the idea is to find the area of the whole figure. I'll go the wrong way. So we need to draw some auxiliary lines in here to break this figure up into smaller pieces that we can easily find the area of. So right now what I see here is this slant line right here and this one. So I'm going to draw an auxiliary line here and then one right here. And this right here is going to be a trapezoid. This is going to be a rectangle. And I will have another rectangle right there. So I've got 3 figures that I need to find the area of. Now, they also give you in the picture, I didn't write all the numbers in, that this side right here is also 65. And this side here is also 42. And from here to here is also 83. So I didn't write those numbers in, but that's what those are. What that does is prove to me that if this side and this side are the same length, that this would be more of a rectangular figure in here. So let's go ahead and figure out the 2 rectangles first. So 66 times 65 is 4290. So that is the area of that part. Now 20 times 42 is 840. I'll write it out here because it's a little tight in there. 840. And that's an area. So now let's look at this one right here. So this trapezoid. So this base right here is 66. And this base is 20. So the area equals 66 plus 20 times the height, which we don't know yet, but let me finish this up and put a 2 right there. So the height from here to here. So if this distance from here to here is 83, and then from here to here is 65, it's 83 minus 65. So that height, that distance right here is 18. So that's the height. So 18. So on my calculator, I just go like that, hit the fraction bar, and say 66 plus 20 times 18. Put a 2 there. I didn't cross cancel this time because that's not a big deal. 774 for the area in here. So 774. Since that's already in my calculator, I'll add the 4290 plus 840. And the whole thing is 5,904. So that's the area of that whole thing right there. Now there's another example in here I kind of want to look at that I like. On page 6, well, at least it's not on 666. That would be a bad page. It's on page 667. And it's a figure that looks like this right here. Now this, I just took the cross section. I didn't try to draw that three-dimensional figure. I only just took the cross section of it. So the idea here, first of all, there's two parts to this. The first part is just to find this surface area in here. All right, so we need to draw some auxiliary lines. Okay, so, and I didn't put any numbers down here. The numbers are the same as they are up here for this. So the area of this down here is the same as the area of this right here. All the dimensions are the same. It's a mirror. So what I need to do is I need to find the area of this figure right here. So let's draw some auxiliary lines in there. So this area right here is a trapezoid. This is a rectangle. Now, this side right here is 0.7 and this is 6. So I can find the area of that right there first. Might as well just go ahead and do that. 6 times 0.7, that is 4.2. And I'll write it over here just to keep it from getting too cluttered in there. 4.2, that is an area. Now I need to find the area of this trapezoid right here. Well, one of the bases is 6. From here to here is 6. And the other base right here is 0.8. Okay? So I can write that right over here. The area is equal to base 1, we'll just call that 0.8, plus 6 times the height divided by 2. Well, what's the height here? This is 1.1 from here to here and 0.7 from here to here. So 1.1 minus 0.7 is 0.4. So the height from here to here is 0.4. So I will put that 0.4 in right there. And then I will multiply, got fraction bar, 0.8 plus 6 times 0.4, put the 2 And I have the area of that trapezoid right there is 1.36. And that is that trapezoid. I don't want anything to get off the screen. Okay, so now what I need to find, I've got the area of this. I just add those together. I'll do that in a moment. So I've got the area of this one. That's also the same as the area of this one. Now what I need to find is the area of this rectangle from here down to here. Well, I have the width already is 0.8. I just need to find this distance from here to here. Well, the total distance, I don't know, that's a messed up 18. The total distance from here all the way down to here is 18. So to find the distance from here to here, I take 1.1 and subtract it off, and then another 1.1 and subtract it off. So 18 minus 2.2 is equal to 15.8. So the distance from here to here is 15.8. So 15.8 times 0.8 is 12.64. So forgot to circle that. 64 is the area right there. Circle it because I know that these are my main numbers that I need to add at the end. So, because this area and this area right here are the same, I'm just going to go ahead and add those together. 1.36 plus 4.2, that gives me 5.56. So I'm just going to multiply that by 2 to add in this one. So times 2 is 11.12, and then I'm going to add this one to it. So my area for the whole thing is 23.76. What are those units? Inches. Nope. I think that it's feet. It's going to have to be feet. It wouldn't be inches. It wouldn't be that small. Feet squared. Now the second part, or maybe it is inches. I can't tell if that's 2 marks or 1. That's got to be inches. Inches squared. Probably should put my glasses on. Oh well. Anyway, so the surface area here is 23.76 square inches. Okay, so the second part of the problem says that the tensile strength on this beam is 52 pounds per square inch. So tensile strength, in case you didn't know, there's 3 main kinds of strengths. You've got tensile strength, shear strength, and compression strength. Tensile strength is the strength that an item resists by pulling. Like if I had an object like this right here, and I had a hole here and a hole here, and I put a rope or a string or something through it, and I pulled on it. Tensile strength is the ability of that object to resist being pulled on. Okay? Shear strength is the ability of an object to resist being cut, like a shear, like a scissors. So if I'm holding it here and I'm pushing here, pushing down, and that is the ability of this object to resist being bent right there, or anywhere along that line. Compression strength is just simply pushing on something, just setting a weight on an object, its ability to resist that compression. That's compression strength. Concrete, by the way, has extremely good, by itself, extremely good compression strength, but it has terrible tensile and shear strength by itself without re-rod in it. Now, okay, so this object, I'm going to make the assumption, because usually we don't use these I-beams to resist tensile strength. We usually use these I-beams to resist shear strength, because they go across in building construction like big floor joists, and then the weight is set on top of them, and then that would be a resistance of shear strength. I don't know why they would use this for tensile strength, but I'm going to make the assumption that it would be like hooking something here and pulling it that way, and then hooking something here and pulling it that way. That would be the tensile strength. And we would need this square inches to figure that out. So, 52,000 pounds per square inch. So, let me write that up here. That's where I got room. 52,000, I'm going to write it this way, pounds per inch squared. And then I'm going to multiply that by what we have right here. So what we have here is, I need inches in the top, because inches is in the bottom. No, I need inches in the bottom. Yeah. Because this is an equal sign, not a multiply. Well, I don't know why I did it that way. 23.76 units to units. Now, how many pounds will this hold? So this is a ratio. So this is what I'm solving for. I don't know why I made it the multiplication. I was doing a bunch of unit analysis in class earlier today in another class. I guess I got confused. Okay, so, and this would be a 1 right here. So I cross multiply 52,000 times 23.76 equals that, divided by 1, which, so this should have a tensile strength of 1,235,520 pounds. It's got 23 square inches involved, so it would be 23 times that. Ta-da! Now, let's look at the next one, number 26. Okay, so what we have is a figure like this. Very rough drawing of this one. Okay, can you see that? Yep. So this top is 4 feet 6 inches, so 4.5. This is 12 feet. And what's the bottom? 10.5. Okay, so the first thing that we know is, I think it says it, cross section, it tells me that it's in the shape of a trapezoid. So that means that this side and this side are parallel, because it tells me it's a trapezoid, and I know that a trapezoid has two sides that are parallel, because this side and this side are certainly not parallel. Okay, so first thing I need to do is find the area. So the area will be 4.5 plus 10.5 times 12 divided by 2. It just shows me for using this page twice. I don't know if you can see that right, but that's the numbers. Okay, so going into the calculator, cross that out, put a 1, cross that out, put a 6. So fraction bar 4.5 plus 10.5 times 6. Oops. 4.5 plus 10.5 times 6, 90. So the cross-section area of this is, or the area is 90. 90 feet squared. Now, the other thing that they're asking is to find that distance AB. This is going to be a Pythagorean theorem problem. So this triangle right here, this height is still 12. Now the distance from here to here will be 10.5 minus 4.5, so that's going to be a 6. So the Pythagorean theorem would tell me that the square root of, because now I'm looking for the hypotenuse, this is a flashback type of a problem, 12, square root of 12 squared plus 6 squared, or the square root of 144 plus 36, is equal to 6 times the square root of 5, or 13.4.